So I am the coordinator of the master program in chemical engineering. My name is Elsa Pastor, and I will be talking today about this master program. We have a subtitle in our master program, which is Smart Chemical Factories. This master program will enable you to practice as a chemical engineer. We've been doing that for quite a long time ago, meaning that UPC has had bachelor degrees and master program degrees in chemical engineers for quite a long time ago. But now we are very happy to present you a very renewed master program in chemical engineering. Actually, as the other master of the innovative and interdisciplinary master, it's a new master program that has been running from September 2019. And that's why we wanted to highlight this subtitle, Smart Chemical Factories, because with that subtitle, I think that we are transmitting the message that with this master we will help you and we will give you the tools to get prepared for the chemical industry future, which is actually smart chemical factories. I'm going to talk about that concept in a minute, but first of all, let me give you some main information on our master. This is a 2 academic year master, a full 2-year program, which is 120 credits. And it's going to be delivered during the afternoons, meaning that you will be starting around 3 p.m. and ending around 7 p.m. or even later than that some days. And that's face-to-face. Hopefully, from September, we're going to have the opportunity to come back to face-to-face activities. The language of instruction is English. All activities are in English. And the basic admission profile is a bachelor degree in chemical engineering. What I'm meaning here is that if you have a bachelor degree in chemical engineering, you will be directly admitted. But if you have other bachelor degrees, like for instance, chemistry, biotechnology, or environmental science, or other bachelor degrees alike, you will be also more than welcome to be admitted, but you'll need to do some bridging courses from our bachelor degrees in chemical engineering. At our school, at the EEBE, we have the bachelor degree in chemical engineering, so that's pretty convenient because you might need some of those bridging courses, so you will have the opportunity to do these courses together with the first year of the master, okay? So the aim of our renewed master program in chemical engineering is to train engineers with a higher level of competencies that will allow to deal with current challenges in chemical engineering, like sustainability, like circular economy, like climate change, and to take advantage of the opportunities that Industry 4.0 technology can afford. So let me give you some insights on these challenges and these opportunities that I have just mentioned. You all know that chemical engineering is directly concerned about obtaining different types of products, like solvents, like fuels, like paints, like polymers, like medicines, etc., and offering different types of services, like for instance, water and energy supply, or waste treatment, or waste valorization, all right? So those products and those services are ensuring our quality of life. And in fact, we could say that modern life, as we know it, would just not be possible without those products and without those services, right? But the society demands us to do this job, to produce these products and to deliver those services, ensuring that all this activity is efficient, is sustainable, is economically viable, is safe, and is environmental friendly, right? So these demands are very challenging demands, I would say. And actually, they are framed within the United Nations Sustainable Development Goals, in which chemical engineers have a huge responsibility, have a very important role to achieve them. So I've written in here some keywords that will help us to better understand the activity at present of chemical engineers, and the future, and just the near future that is coming from chemical engineers. And I would say that some of these keywords have become the pillar above which we have built our new master program. Like, for instance, circular economy, right? So circular economy actually involves an efficient use of resources, as well as the transformation of waste products into energy or into valuable elements, okay? So the thing is that this is a very challenging demand. This is a huge challenge. I would put a couple of examples that you all may know and that you would be aware of, like, for instance, CO2. That's a high challenge with CO2, or for instance with plastic materials. Okay, so everybody knows about that, and we have to deal with that. Chemical engineers, we have to work on that. We also have, for instance, the water industry. So we need better treatment processes, more efficient, less energy consuming, to provide the world with drinking water. We have a thirsty world. Our world is divided in most places with highly urbanized areas, with highly populated areas. So there's a huge demand on water, on drinking water supply, right? And in addition to that, in a climate change scenario, as I have just mentioned, we actually need energy efficient technologies. Okay, we can say that our society totally depends on energy. Right, so we need new technologies. We need innovative materials that allow us to generate and to store energy in a sustainable, in a safe, and in an efficient way. So I'm thinking here, when I'm talking about energy efficient technologies, I'm thinking about superconductors, and thinking about nanoparticles, and thinking about polymers for photovoltaic cells, or I'm thinking about biofuels, for instance. So those technologies, those products are actually a matter for chemical engineers, all right? Then we have health and hygiene. Chemical engineers can contribute very much to that topic as well. And I'm going to provide you a couple of examples. For instance, we can talk about the development of biocompatible materials with the organism, or the development of smart drug delivery implants. And I have selected these two examples because you would be probably or most likely taught about those examples, because they are a couple of topics that are actually research topics of our chemical engineering department. I would like to highlight in here that the chemical engineering department at UPC is one of the most active in terms of research. We have several research teams working in several topics, and you will clearly see how the activity of the research teams of the chemical engineering department is very well linked to the knowledge and to the activities that you will be doing in the master. And that's a very good point. That's a very good point. I would like to highlight that, because you will be taught, you will be trained with the state of the art of products and technologies and processes, and that's very valuable from my point of view. Then we have Industry 4.0. So concepts like machine learning, or data mining, or Internet of Things, or virtual reality, they are all those concepts are in today's agenda for pretty much every one of us, right? I would like to say that chemical engineering had much to do with this industrial revolution. And apart from that, chemical energies will have to benefit from those tools as well, right? To get more controllable chemical processes, safer chemical processes, more efficient chemical processes. So we'll be also looking at what Industry 4.0 tools can provide us, how these tools can help us. Then I'm pretty sure that you are familiar with the terms of smart mobility and smart cities. So chemical engineers can also bring some research advances to that. For instance, I'm thinking about developing lighter materials, or advanced fuels, or newest catalysts, or more efficient batteries. Okay, so that's also chemical engineers' job, and we will contribute, and we are actually contributing to that as well. And last but not least, I would also like to mention the food industry. there are some provisions that tell us that by the year 2050, we will be now 9,000 million people in our world. So that's a lot of people to feed. And of course, food industry has to be transformed, has to develop more efficient processes, more sustainable processes to get all that food ready for this huge amount of people, right? So we can contribute, chemical engineers, we can also contribute to that food industry as well. Okay. So with that bit of overview, you might be having the sense that you will get you prepared to develop different types of activities like process or operations design, or safety, or quality, or environmental impact, or research and innovation and training in a wide variety of industries. So you will get ready to get trained for high responsibilities in chemical engineering industries. And when I say chemical, now you understand that I'm talking about not only chemical, but petrochemical, pharmaceutical, polymers and plastics, food, environmental industry, biotechnological industry, etc., right? And of course, when you are thinking of those industries, you are thinking about, let's say, the public, private companies, okay? But let me tell you that our master will prepare you to get into the public industry, public jobs, public administration as well, and the university, if that's what you like. And I would like to mention that because our master program is smoothly linked with our PhD program, meaning that if you have finished your first year of our master program, you can get enrolled to our PhD program, developing your doctoral thesis as well. Okay. Right. So let's talk about a little bit about the master structure. We have 4 semesters. With courses of 6 credits and our final master thesis of 18 credits. So our courses are courses within 4 types of disciplines. We have 2 compulsory disciplines and then 2 specialization tracks. The first block of courses is what we call products and process engineering. So that is a core advanced chemical engineering, okay? And then we have some courses within the industrial management skills, all right? So those 2 disciplines will gonna be compulsory, and then we have 2 specialization tracks. The first specialization track is the Smart Polymers Engineering specialization, the SPE track that we call it. And the second one is the Green Chemical Process Engineering specialization track, the GCPE track. So if you choose to do the SPE track, you will get the technical and the scientific skills to develop advanced polymer materials. So that means that you will be trained to synthesize, to characterize, and to process polymers and biopolymers for a wide range of applications. For instance, tissue engineering, energy storage, optical data storage, environmental protection, medical applications, etc. Right? Then if you choose to do the Green Chemical Process Engineering specialization track, the GCPE specialization, you will have the technical and the scientific skills for engineering sustainable chemical process. And what does it mean? So it means that you will be trained to develop and to transform classical chemical process plants into circular economy models by integrating new chemical routes or innovative process and technologies for the benefit of environment, for the benefit of society, and for the benefit of economy, okay? All right, so those are the main disciplines, and let's have a look of how our program looks like. As I said, there are 4 semesters. Every subject has 6 credits, so meaning that you will be having 30 credits in every semester. During the first semester, we're going to have compulsory subjects of these 2 mandatory blocks, the products and process engineering and the management block. So you'll have data analysis and pattern recognition. For those of you who have attended to the last talk, that's a common subject with the other master. Then we have biotechnology, processes, and polymer industry, and we have chemical and catalytic reaction engineering. Then we have 2 more compulsory subjects, which is sustainability and circular economy, and also technological innovation, okay? Then during the second semester, you will be able to choose your specialization track. Here you can see how let's say the yellow or yellowish boxes are those subjects from the Smart Polymers Engineering specialization track, and the green or greenish boxes are those subjects related to the green chemical process engineering specialization track. So during semesters 2 and 3, you will be having 2 optional courses plus 3 compulsory courses, okay? In semester 2, in terms of compulsory or mandatory courses, you will have polymer physics, process control, and management and organization. And then you will be able to choose either SPE track or GCPE track, meaning that if you choose SPE track, you will be having experimentation and instrumentation and polymer transformation processes. And if you are choosing GCPE track, you will have membrane processes and technologies and industrial water technologies. All right. Let me tell you that I would suggest choosing one of those tracks if you have really an idea that you like polymer industry and polymer research very much. So if that's the case, you can choose the 6 subjects, and then you will have explicitly the mention of your specialization track in your title. The same way, if you really like green chemical processes, so you can choose the 6 subjects that are forming this specialization track. But if you are not really, if you don't have a clear idea of what you want to do, you can also pick some subjects from here and there, and then complete the 36 bunch of credits in terms of specialization, right? In that case, you won't have explicitly the mention of the specialization track in your title, but that's totally okay. That's totally okay. That depends on, on your expectations, on how you want to orientate your career, but that's totally fine, okay? Next, semester 3, so that's autumn from the second year. In terms of compulsory subjects, you'll have nanotechnology, risk and safety of the chemical industry, and waste resource technologies. You see, if apart from all the specialization tracks, you'll see how with the progress and process engineering and with the management courses, you have a full basis of all the new technologies and all the new processes that the future of chemical industry will challenge you. Then in terms of the optative subjects, you'll have chemistry of polymerization and biopolymers and bioplastics for SPE, and process integration and advanced catalytic reactors for GCPE. And finally, during the 4 semesters, you'll have 2 more subjects from the specialization track. For the polymers track, you have advanced materials and design of equipment and coating technologies. And for the GCPE track, you'll have computational fluid dynamics, CFD, and circular process engineering. And then you'll have a final master thesis of 18 ECTS, right? So that's pretty much how our master looks like. Right. I would like to let you know, you might probably know it, but I think that that's a good opportunity to remember that the chemical industry here in Catalonia is very powerful, is very strong. Actually, the 43% of the total Spanish industry is in Catalonia. We have more than 750 companies in Catalonia. We have big names, like for instance, Solvay or BASF or Dow Chemical or, I don't know, Chilworth or whatever. We have lots of those really big names, but we also have short and medium enterprises devoted to all those different fields in the chemical industry, which are also leading companies in that sector, okay? The turnover per year in Catalonia is just terrific. It's 27,000 million euros. So that is that the activity is very good, and I'm highlighting that because there are a lot of job opportunities here in Catalonia. And I say that because we promote our students to do work placement agreements with the UPC and companies. So if there is a case that a company is offering a solid learning project for our students, we are more than happy for you to go to the company, to do your job, and to receive up to 18 credits from the pool of the 36 credits from the specialization track. Meaning that if that's your option, if you find a solid learning project with the company, then you'll have that experience of working in a leading company. You'll have a very good experience for that, I'm pretty sure. But then you won't receive, let's say, the mention of your specialization track in your title. But that's also okay. I mean, that's not a big problem. And just let me finish talking about mobility. Of course, if you are interested in doing an Erasmus experience in another university in Europe, you would be more than welcome to do so. Our school has learning agreements with many different schools, technical schools and scientific schools all around Europe. And some of that schools have very powerful chemical engineering master programs as well. I would like to mention here, for instance, the Enginyeria in Paris or the University of Lyon, or some other universities in Italy, like Bologna, like Politecnico di Torino, like Sapienza in Roma. We also have agreements with universities in Belgium, like the Leuven Catholic University, or we have also nice agreements with schools and universities in Sweden, like the School of Engineering Science and Chemistry and Biotechnology in Stockholm, or the Chalmers University, okay? We also have agreements with Slovenia, with the University of Ljubljana, or with the National Technical University of Athens in Greece, or with the Instituto Superior Técnico of the Universitat Técnica de Lisboa, or the Brno University of Technology in the Czech Republic, just to mention a few, because we have more than that. So I'm pretty sure that if you are keen on going abroad, you will find a perfect place that suits you, your interests, and your expectations. So I don't know if that was too quick or not, but I'm pretty much done. That's my contact.